When making changes to the network, it's really nice to be able to upload and test out your changes before actually deploying them to production. And in a pipeline, it's really almost imperative so that you can ensure your changes aren't going to cause problems within our production environment. ACT, or Arista Cloud Test, is a cloud-based virtualized set of devices that Arista created to allow for testing of changes, for creating a digital twin of your physical topology. And AVD works well with ACT by creating the topology files, generating the configurations, and then giving you an easy way to upload those. That's what we're going to do in this video. We'll be using the Single Data Center L3LS example topology from AVD. It's a spine leaf topology using EVPN VXLAN within the spines and leaves, and then we do have some L2 leaves defined as well. And you can find this under the example sections within avd.arista.com. Go to the examples area and single DC L3LS. You'll see there's that topology file there. And you can download all of these examples if you click on how to use AVD examples and scroll down to the bottom using an Ansible playbook. So let's get into the files themselves. Before we get started, I do want to make some changes to this because this is already set up for a virtual environment. But let's pretend like the repository is actually a physical device. If we had physical devices, one of the things that we would have to do within AVD is define our platform as an actual device. I'm going to do this by calling this a 7050X3. It's our Trident series of devices, and I'll do this under all of the platforms: the spines, the L2 leaves, and the L3 leaves. 7050X3. And this is just where you define the platform. The other thing that has already been done for us, and it's actually called out, if you go to fabric variables and you look at the point-to-point networks, you'll notice that 1500 is already being used, but this 9214 is included as a best practice. So if you're using actual physical devices, 9214 is recommended. So what I'll do is uncomment that and comment out this 1500. So those are two things that make this environment more production-like. Now let's run the build, and to do that, it's an Ansible playbook -I. Our inventory file is inventory without IP, so inventory without IP.yaml build.yaml. This is just a regular build. It's using EOS designs and EOS CLI config gen. And you can see that we do have a number of changes. Let's go take a look at those changes. And we'll do that in the source code area because this is tracked since it was cloned from the original examples. So we can see the differences that came out. We changed our MTU, so now 9214 is what we're using in our production environment. And that goes for the SVIs as well as the point-to-point areas. And the other thing is this update wait install came in. And update wait install just tells a physical device to wait on updating neighbors with routes until those routes have been installed in the hardware. This causes problems within our virtual instances, so we take it out. When we create our digital twin topology, we're going to need to remove that, but we'll take a look at that as we go along. I'm going to clean up some of these files. And the next thing we'll do is look at the digital twin variables that we have available to us. I'm back at avd.arista.com, and I'll go to the user manual, AVD design under the EOS designs area. And on the far right side, if you scroll all the way down to the bottom, we have a preview of digital twin settings. So preview just means that some things could change, but for right now, this is a great area to go and leverage for this. Under the variables that we're going to look at, I'm going to grab the variables down to the ensure eAPI access. And that's what we'll walk through next. I'm going to take those variables and apply them to our fabric file. So this will occur to all devices. And let's start walking through these areas. So under digital twin, the first thing we have is the environment. Now we do have intentions of creating other environments for digital twins. For now, ACT is the only one. I'm going to go in and set that to ACT. I could leave it blank. For the OS version, I'm going to use 4.35.4m. That's just the latest maintenance release at this time. And let me show you where I got that. If we do go to ACT and under the topology area, if you choose available nodes, you can see that we've got VEOS devices listed, and these are all the versions that we've got within ACT. 4.35.4 is the latest maintenance release. So that's the one I'm going to choose. Within our example, the username is Arista, so I want to use that, and the password is Arista, and I'll use that. The reason I'm doing that is because I will want to log in a little later through the API. You can choose to enable or disable internet. By default, it's false. I'm going to make it true, just so we could use things like external DNS if we wanted to. If we wanted to set up to CVAS or something on the internet, I'm going to make that true. And the reason we do have a true and false there is the default routes matter within ACT. So if you have a default route, an all zeros route, that can mess with the internet default route. If you have it set up for false, you could put an all zeros route in and test the default routing. And you may want to do that if you were testing some routing within your environment. If you do just want to use the internet access and follow the default route, the actual default route to get to the internet, you would enable that with true. The ensure eAPI access allows us to access the API on the virtual instance if we have a non-default route set. In this case, we have a management VRF set. So I'm going to make this true, and that will allow us to access the default VRF when applying configurations. So these are the variables that we'll use. And in order for us to actually create a digital twin environment, there are some things we need to look at on the playbook side as well. So let's go back to our documentation. And this time we're going to scroll back up to the beginning of the digital twin area. And you'll notice that we show a normal playbook here that we do with EOS designs and config gen. And then we have a few different variables that we're adding for the digital twin. So I'll take these variables and copy them, and we'll go back to our build section. And I'm going to create a new playbook. I'm just going to copy it. You can see over here, I will call that build-dt for digital twin, just so we have a different playbook. And I will place those variables right here. So these variables include the output directory name. It's going to create a digital twin and intended area for the configurations, and then documentation. It will also create under the digital twin directory. And we will just say that, yes, the digital twin mode is on or true. It is set. So now if we run that, and I will just up arrow, do a -dt to run that playbook. You'll notice that a new directory was created here called digital twin. Under there is both the intended and documentation. We have configurations for these devices and documentation. The only thing really that should be a lot different is your fabric. We have a fabric topology file, and this file is used for ACT. So we'll be uploading this in a moment to the ACT lab, and that allows us to have our devices defined with the version, the username and password we're using, and then the links for connecting the devices together. One thing I wanted to call your attention to, though, is the difference in the configs automatically that this integration gives us. So what I'll do is, here's the intended folder from our production environment, and I will use a VS Code function called select for compare, and then under our digital twin area, select that same device and do compare with selected. Let's take a look at the differences. You can see that we do have this VRF default in a no shutdown state, and that's for our API. Because we have the VRF management, we do need this same thing so we can access that API. Notice that we still have our MTU set to 9214, so that's going to be an issue. We'll take a look at that in a moment. And then the update wait install, so that was removed. That's part of this feature because it's for ACT. It knows that ACT would rather not see the update wait install there. Therefore, it will remove it automatically. We still have a few things to take a look at. One is the MTU. Another, I'm just going to show you, maybe I want to use a different DNS server. So right now our DNS server is set to 192.168.1.1. What if I want to set it to 8.8.8.8? How do we do that? And then also I want to show you one other thing, and that is the default route. So I mentioned because I enabled internet access, I need to not have a default route set. And we do still have one there. And I'm going to remove this default route by using another construct and this is actually an Ansible construct that deals with variable precedence. We're going to use a built-in function within Ansible, and that's called the include_vars function. So the first thing we'll do is essentially overwrite some variables whenever we use this build-dt playbook. The first thing we'll do is create a file for that, and I'm just going to call it ACT override. that you can call it whatever you'd like. It's just a YAML file that will have the variables in it. And from my group vars area and the fabric variables, one of the things that we talked about already is to have the point-to-point uplink MTU set to 1500. So I'm going to grab that variable. I'm going to place it here. Then the other one I mentioned was a DNS server. So this is not required. I'm just showing you how you could do another variable if you had variables that you wanted to change that fits your environment best. So this is an example of how you would set DNS setting. You take the same variable, redefine it in this override, and then we'll use that specific variable. And the last one that I mentioned was that default route. That default route lives in this dc1.yaml area under management gateway. So I'm going to take that variable, place it in here, and then I'm just going to make that null. And that way this will get rid of our default route. So in order to call this ACT override, we are going to have to add a task within our build DT playbook. And I'm actually going to copy this task in because it does have a few lines I don't want to mess up. So we give it a name, the task name. We have the Ansible built-in include vars. And then we're just going to call a file. That file is in our inventory directory under this repository, and it's called actoverride.yaml. Again, this is just an Ansible construct that you can use. It's called include vars, and we just feed it a file to override some specific variables. So I'm going to run the playbook one more time. And I'll close these files. So I'll do our comparison as we did before. Select Leaf 1A to select for compare. And then I'll go under our digital twin configs and I will compare with selected. So now we see a number of other changes. One of the changes we see is, okay, we've got our name server now that's set up. We still have that eAPI access in the default verf. Okay, our MTU is now 1500. That's great. True for our SVIs as well. And we got rid of that default route, so that's good to see. And the update wait install is still good. Okay, so now we're actually ready to upload this file, or upload our topology file and connect to it and deploy our configurations. So let's grab the documentation and fabric. I do know that there is another fabric topology that's already on ACT within the ACT instance I'm using. So I'm going to call mine Fabric Topology 1. These do have to be unique within ACT, so I'm just going to make this 1. And now let's go to ACT. Once in ACT, under the topologies area, the very first thing you do is add a topology. So we'll add the topology. We have to upload the file. So here's our file, Fabric, and then Fabric Topology 1. Open that. And then we click Validate. The validation just says, did you choose the right or an EOS version that was within ACT? Do you have things connected to each other that make sense? Are all of the variables, does everything look right? So it will have the topology file here, and then you give it a name. Digital, let's do digital twin Fabric Topology 1. Save that. And once that's saved, you can go create a lab. You'll click on, you go to the lab area up top, you click Add Lab, and then you'll give it a name. You will select your topology. Mine was called Digital Twin Fabric Topology. And you'll save that. Next, after that lab is created, you'll double click on the lab. So anywhere in this area, double click on it. It will take you into the lab itself, and you'll click Deploy. Once you click Deploy, it does take a few moments. While this is happening, let's go and work on the playbook for deploying to the devices themselves. I'm going to close our directories here, and we've got a deploy playbook that's actually included with us, and that's going to deploy to the API. And that's going to be a great way for us to get to our devices and deploy. Now, the one thing that we need to do is, by default, this deploy playbook, or using the eAPI, is going to look for the intended folder in the same directory as your inventory and everything else. So we need to create another playbook so that we know we're deploying our digital twin and not to production. We're going to do the same thing we did last time. Copy that deploy playbook, copy and paste. Let's rename the deploy to deploy-dt, and we're going to set a variable, and that variable is going to be our root directory. So we're going to set the root directory meaning where are we looking for files. We're going to set that to within our inventory directory, and then digital twin, and that will tell it to grab from the inventory directory / digital twin, which is right here, and you can see under there that's where intended is, and that's where under intended we have our configs and structure config, which is what it's going to need to deploy everything. Now, one other thing that we'll need, and you can do this a few different ways. So you can come into your inventory and you could add an Ansible-host to give it an IP address as well as the username and password. But there's another way to set up your deploy mode, and that's using a secondary inventory. So you can basically concatenate inventories, and they'll combine variables into one. And that's what we're going to do because ACT does give us an inventory file that we can use. So let's go and see if ACT is up and running. All right, our devices are running at this point in time. And you can see at the bottom there's this download inventory file, and we can click on that and it will download that digital twin file to our local machine. I'm going to grab this digital twin file and put it into my local directory here. So that is in my downloads folder. So copy that digital twin file locally. And now we'll access that by using Ansible playbook -i. We'll call our inventory without IP, and then we'll do another -i, and we'll call the digital twin file, and then we'll use the deploy-dt.yaml playbook. Let me show you the digital twin file here. You can see it's got the IP addresses that are associated with the devices, as well as the user and the password to use. So now we're going to use those two files to push our configuration out to the devices. Before we do, one other thing I wanted to show you. If I click within here, I can get to one of the devices, so leaf 1A, and I just wanted to show you that if we do a show run, we have a default configuration. We don't have any BGP. We don't have a lot of the IP stuff that we've got set up. Now let's go run our playbook to deploy. And that will go out to each of the devices and place the configuration on it. And then we can go take a look at each of the devices. All right, it's completing that. Let's go take a look in here and we'll do a show run. And now you can see we've got all of our VLANs and IP addressing and BGP and everything. And we are all set to do whatever we need to do. So show IP route. There's our routing for the fabric. We could even do a show IP route VRF management. So if we wanted to see management, there's not a whole lot to see there. This is what we're wanting to get after with regard to a digital twin. Hopefully this was helpful and that you'll find this feature for digital twin under AVD working with ACT to be super helpful. Thanks for watching.